Welcome to solverfy.
This question is telling us about the Milky Way, and it's a galactic disk. So I'm going to create this galactic disk. I'm going to put the sun there. And the distance from the center is 30,000 light years. So that's going to be our R here. And light year is 9.46 times 10 to the 15th power meters. Okay. Now its speed is, trying to make an equal sign. Oh my goodness. Let's try this again. Equals, okay, 250,000 meters per second. Okay. What is the period? Well, the period is 2 pi r over the velocity. We know all these numbers. So let's put that in a calculator. 2 times pi times r, which is 30,000 times light years, which would be 9.46 times 10 to the 15th power, divided by 250,000 meters per second. So I am getting 7.13 times 10 to the 15th power seconds. Now, the answer in the back of the book is in years. So let's convert this to years. There are 3,600 seconds in an hour. So I'm just multiplying by 3,600. Or rather, sorry, dividing by 3,600. There are 24 hours in a day, and there are 365 days in a year. So now, since I divided by 3,600, I divided by 24, and I divided by 365, it gives me 2.26 times 10 to the 3/68th power years. Let's move on to part B. Mass of the galaxy, order of magnitude. Interesting. I'm going to use t squared equals 4 pi squared r cubed over gm. And therefore, m, which would be mass of the galaxy, is gt cubed over 4 pi squared. Where did I get cubed from? Don't know. GT squared. Okay, let's redo that. I'm not sure why I just wrote that. We're solving for m. That's all we're doing. M is going to be 4 pi squared r cubed over gt squared. Let's put that into a calculator. 4 times pi squared times radius to the third power. We were given radius as 30,000 times 9.46 times 10 to the 15th power, which is a light year, cubed. Okay, so I did 4 pi squared r cubed. Whoops. And now I have to divide by gt squared. All right. Whoops. G is 6.67 times 10 to the negative 11th power. And t squared, we have to use t in seconds. It was 7.13. Well, I wrote it down for you guys. 7.13 times 10 to the 15th power. Squared. Okay. So I actually get 2.66 times 10 to the 41 power kilograms. Now, the book says 10 to the 11th power, so somehow I am way off. So when you make a mistake, just look through your work and figure out where the mistake is. And actually, I found out that I did not make a mistake. It was just written incorrectly in my system here, the numerate system. So we'll get that corrected. But now we can move on to C, because B is correct. If the sun is a typical star, then approximately how many stars are in the Milky Way? Well, the mass of the sun is 1.99 times 10 to the 30th power. So all I have to do is take that mass and divide by the mass of the sun. We put that into a calculator. Take that mass and divide by the mass of the sun, which is, again, 1.99 times 10 to the 30th power kilograms. And I get 1.34 times 10 to the 11th power stars. And that, again, is the answer in the back of the book. Actually, in the back of the book, it says 10 to the 41st power here. And it says 10 to the 11th power here. So 10 to the 11th power, I'm just interested, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's going to be 100 billion stars. 1,000, million, billion. Yeah, 100 billion stars. That's interesting to put it in standard form. All right, thank you.